Resuming lesson 6, applications of linear functions. And the overall goals for these, for lesson 6 is to solve contextual problems modeled by linear functions and to solve contextual problems involving the characteristics. Now, this last one here, quadratic functions, we will be covering this one in lesson unit 4. But for the remainder of this lesson, we'll be focusing on linear function. So far, we've completed linear application when equation is given. And the previous lesson, we looked at application when a table of values given. So the last one, we looked when the table of values is given here. And the previous question when the equation was given. Today, we are looking at solving a question when either a part of a table is given or there's a set of a verbal instruction is given. We have a completed table of values. So this is on page 33 of your booklet. And as in previous ones, we'll need your graphing calculator, or if you're using Desmos, you probably want to use Desmos also. Okay, this is my previous set of, should have done that, but here we go. So these are the two pieces of technology you will need. And you probably want to have handy with you your instructions for using a graphing calculator or instruction to use your Desmos. So these are the things you'll need. So let's look at a quick question here. We need to complete a set of data. Now here we have a student council is planning to hold a fundraising dinner. They will profit $8 per dinner ticket, and the other costs for the dinner are for the hall rental and the music, which total to $300, filling the table in this situation. Now, notice this started off when 0 tickets sold, you're minus $300. In other words, this is your deposit. Okay, they said they will profit $8 per dinner ticket, and the other costs for the dinner are the full hall rental and the music. So they have to pay this for the hall rental and the music. So this is money they will spend. They won't make any profit. So based on the number of tickets sold and the down payment, that will determine the amount of profit they'll make. They want to make some money. That's the idea of fundraising. So they're in a hole. So for every tickets sold, right? They will profit $8 per dinner ticket, and the other cost for dinner are full. So for every dinner ticket sold, they will make $8. So they sold no tickets, they have no profit, but they've already put $300 down to the for the rental hall and the music. Now, if you want for 15 tickets, how much your profit will be? Now, for 15 tickets, it's $8, right? So the profit here would be 15 times 8. So in this case, it'd be $120, right? So 15 times 8, let's make sure I'm on the right track here. 15 times 8. So $120. But they're already in a hole for $130. So to find how much their debt is reduced by, or their profit, it'd be minus 300 plus 120. So minus 300, that's what they started off with. It's like you owe $300. You're actually in debt of $300. So it's a minus. Minus means you're in debt. But you made a profit of $120. So how much money do you have right now? It's negative 300 plus 120, or you can say 120 minus 300. So I'll go my calculator here. I have 120. I'm going to subtract 300. That left me with negative 180. So I have a negative $180 here. Now, if you were now to $8 per ticket, now you've sold 15 tickets. Now, after selling 25 tickets, right, how much would that be? Now, you're still working with $300, right? So if you were just sold 20 tickets, let's say we put that out of here, okay? So we say we have sold 20. So you're still in a hole of $180. But you say, okay, I continue to sell tickets and I've sold 25 tickets. So how much would that be? It would be 25 times 8. Let's put my calculator here. 25 times 8 gives me $200. So now it's $200. Okay. So now that will be negative 300, right? Plus 200. So you now have a profit now of a negative 100. So you still haven't made a profit yet, in the positive, right? You're still in the negative. Now, if we were to sell 50 tickets, now it would be 50 multiplied by 8, and that will give us 50 times 8, $400. So give me 400 here now. So now my minus 300 plus 400 will give me 100. Now I'm in the positive. Next, they decided to continue selling and they sold 100 tickets. So it would be 100 tickets times 8. It'll give me $800 here. So now this will be negative 300 plus 800. So I have a profit now of $500. So be careful with your algebra here because you started off as negative 300. And this is the total tickets sold. So don't add them because this is just if you were to sell. If you sold only 15 tickets, you'll be negative 180 if you were to stop there. But you continue selling the tickets. So now the total is you sold 100 tickets, you have a profit of $500. So now we're going to create a scatter plot. Okay. Zoom out. Now we've got our table. Now this is a part that's different from the first question. The first question, you're given the equation. Then the next question, you're given a table. Now you have to complete a table. So the verbal description is given here. The scenario is given. Now, create a scatter plot. Now, number of tickets, this will be your x coordinates, or x1, and this will be your y1. Or L1 in the graphing calculator, L2. So now this will be number of tickets here. So number of tickets sold, so we label it. And here we have total profit. And that's in dollars. So we can call this T here if you want, and this would be profit if you would like. Here's P. Say profit, the total cost, number of tickets, or you can put this N, doesn't matter, number of tickets, but this would be your X value. Now notice we have a negative here, so we have to extend our line down here in negative because we wouldn't have sort of a negative amount here in our sketch. Now, we have up to 1,000. So here we have up to 100 tickets. So we can have there, let's see, 10, 20, 30, 40, 50, 60, 70, 80, oops, need to get excused, 90, 100. So this is 0. So you have 0 here. It goes up to what, maybe 1,000. So we can make this increment of 100. So we have 100 here, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So we have 1 is 2, 3, 4, 5, just to be perspective. So that's my scale. Down here would be negative 100, negative 200, negative 300. So I'm just doing an approximate. I can go up continuously here. 11, 12, 13, 14, etc. Now I'll plot my points on the graph. So at 0 is negative 300 right here. Just zoom in a little bit here. So when x is 15 is negative 120. So 15, negative 120 approximately here. I'm giving it a little sketch here. At 25 is negative 100. Oh, maybe it should be a bit lower. So 15 would be about here. At 25 is negative 100. At 50 is 100. It's about here. And 100 is 500. So it's way, let's see here. So I have my ruler and I construct a line of best fit. So it's pretty close. I'm off a little bit. It's a sketch. So I'm going to. Now, for those who are interested in domain, your domain is starting from 0 because the number of tickets sold. So if I were to write a domain here, start from 0, and realistically, my tickets are 100 tickets here. Maybe you can see maybe they're looking at selling maybe 100 tickets here. So still 100 tickets. So that's your domain. The range, on the other hand, start from negative 300. It's my lowest point here. And it goes up to, in this case, it's 500. So that's your range, how high it goes. So, okay, in my graph here. Now this could go further if you want. So that's my scatter plot. But now I need to, now I ask you here, is this a linear, now let's look at the questions here. Is this a linear equation? And the answer would be yes, because each ticket is going up. Each profit is $8 per ticket. Oops, go back here. The profit is $8 per ticket. So that's why this line, now I should move it off here. We'll see this here. It should be there. And the answer is yes. So this is a linear, this yes. Okay. This is a linear relation. Because each ticket, the profit, each ticket produces or gives a profit of $8. Now, we'll derive the equation in a minute, but now once we have our set of data, now we're going to use our calculator. Okay, I'm going to zoom out here so we can see our data. That's our big picture. That's our question sheet here. Now I need to graph this. This is my sketch here. I'll use Desmos for us here. Those Desmos fans here kind of go. I'll zoom in a little bit here now so you can see it clear. Oops. This is my x1 and y1. So using our sheet again, we're going to use Desmos. So step one, and now I need to enter the set of data into Desmos. So I press my plus sign, go to table, and enter, this would be x1, 0, 15, 25, 50, 100, and the xy1 will be negative 300, negative 180, etc. So let's do that right now. So we have 0, enter, 15, enter, 25, enter, 50, enter, and the final one is 100. Then I move over to my y1, which is negative 300. Let's enter negative 180. Negative 100. $50 is one. Now we start to make some profit. And 500. Okay, we can press the plus sign there. Oh, sorry, I didn't do that correctly. 500, there we go. Press the plus sign. Oops. And that will zoom in to our data. So notice very similar to what we have here. So negative 300, that's your, now we need to enter our equation. We've done all that. We need to get our equation in, which is this wonderful equation here. So I'm putting that into line 2. Okay, y1. So I go to y1, with a tilde, m, x, and you have to put your 1 in there. So my equation, not yet, but plus b. Now you go back to b, and there's my line of best fit. Excellent. Now my equation is y is equal to 8x minus 300. Okay, now we've done that. So we can write our equation here. Y is equal to 8x minus 300. And I'll explain to you. Now, negative 300 is your y-intercept, which crosses the y-axis at negative 300. 8 is your slope. It means each ticket sold make a profit of $8. That's why that number is indication of a straight line. See, the profit for each ticket doesn't change. So each ticket, the profit is $8. That's what that interpretation means. Now, using Desmos, how many tickets do they have to sell in order to break even? To break even means to have a profit of $0. Right? In other words, you want to find the x-intercept. So this is the x-intercept. In other words, when x is equal to 0, sorry, y is equal to 0, when y is equal to 0, we get this point here, y is 0. So this point here, y going to be equal to 0. What is x? The x will tell you how many tickets they'll have to sell to break even, right? Y equal to 0, which is $0. And x will be equal to the number of tickets. So x is 0, x is the number of tickets. So in other words, find the x-intercept. We need to find the x-intercept. That's what we're doing here. Okay. So when y equals 0, what is x? And let's break it even. So let's do that on Desmos here. So now I don't really need all that. So now I need to find my x-intercept. So they would have to at least sell 38 tickets. Now you have to round up. 38, 37.5. Okay, the light on the camera is actually reflecting off the phone. So they have to have sold 38 tickets. So we round up. So when we do, let's write that down here. So when y equals 0, x equal to 37.5. So it means they will have to sell, 38 tickets at least to break even. In other words, to have a profit of $0. So Desmos is quite straightforward. You find the x-intercept. Now, the next question now. What is the profit if 800 tickets are sold? So now, x is 800. Sorry, 180, sorry, 180. What is y? So with Desmos, we are going to go back to our next line. We're going to go to a line here. And we'll say when x is 100, that's the number of tickets. We'll find x is equal to, go back to my pad here, 180. What is the y? So now we have our equation here. Now we need to zoom in. So there's my 180, the green line. I tap on it again. Come on. So $1,140. So if 180 tickets were sold, then they'll have a profit of 180. So y is equal to 100. Now y is 1,140. So that will be $1,140. Now the next point, if their goal is to make $1,000, how many tickets do they have to sell? So now this is your y value. Y is equal to $1,000. What is the x? And in Desmos, we do that again. We go to our next line. Now, by the way, do not remove your equation or data. Just go down to the next line, number 4. In this case, we have y is 1,000. Okay, y equals 1,000. Now you find, now we zoom in here. This is my y 1,000. So they'll have to sell at least 163 tickets. So that will give me a 162.5. So they will have to sell 163 tickets to make a profit of $1,000. For the graphing calculator, this function, I'll leave that as the same process as before. I'll let you work that through. So here where you're given a verbal description and a chart is given and you have to complete it. So from the verbal description, you can complete the chart and then answer the questions regarding doing a sketch. So that's the question regarding verbal description given. The next question example we're looking at, which is the last one in this series, you're given a verbal description and nothing is given. You have to complete the data. So let's look through this one here. In this case, I'll use a graphing calculator. I'm alternating between the two. So here, you're said there's 8 centimeters of snow on the ground. Is melting at a rate of 0.5 centimeters per hour. Complete a table below. So we have time, is just our x-axis here, and amount of snow is your y-axis. So we have y and x here. The time in hours, so we start from 0 time. They said every hour, so if you give an indication of every hour, so we're going to increase it 1 hour, 2 hours, 3 hours, 4 hours, and the snow is melting at 0.5 centimeters per hour. Now you started out with 8 centimeters of snow. At 0 hour, you have 8 centimeters of snow. 1 hour later, you have it melted by half a centimeter. So this will be 8 minus 0.5. So 8 minus 0.5 will give you 7.5. After 1 hour, 7.5. Now we have, after 2 hours, now it's still declined by another 0.5. So this would be 7. Third hour, be 7, because you have 7 hours after 2, minus 0.5. This will give you 6.5. And finally, 6.5 minus 0.5 will give you 6. You can continue, just do one more for the fun of it. We have hour 5. This would be 6 minus 0.5 will give you 5.5 centimeters. So you can see the trend. So there's a decrease. Notice it's decreasing. So let's see what this graph would. We do a sketch first. So our time here in hours, start from 0, and the amount of snow. And the unit here in centimeters. So repeat the same description given in your table. And here we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I could do 2, 4. Maybe that will give us a bit of description here. So I have like 2, 4, 6, 8, 10, 12. So after 20 hours, now going up now, we know we have a maximum of 8. So we can, this is 1, 2, 3, 4. The good part of this one here, you know your limit here. This will be your y-intercept. Do 9, but I'm just gonna. Now let's plot these points here. At 0 time, we have 8. After 1 hour, which will give us what, 7.5. 2 hours, 7. 3 hours, we have 6.5. See this trend. After 4 hours, we have 6. 5 hours is 5.5. Now, and then you can go down. Let's see here, approximately 16 here. Now I didn't do mine accurately, but I'll have an idea. So my graph is actually going down. Oops. Since this right here is about 6 and. Now it will stop here, because that's when it stopped melting. No more snow at this point here. The time. Now this is my sketch. Doesn't mean it's precise. Now we have to enter this into our calculator to find our exact graph. Now let's answer the question here. Is there a linear relation? And the answer is yes, because the snow is melting at a rate of 0.5 centimeters every hour. Okay, sketch a linear regression equation above and write the equation below. So we're going to get that equation in a minute. So we can say here, yes, it is a linear regression. Really, it is a linear relation because the snow is melting at a constant rate, meaning the same rate of 0.5 centimeters per every hour. Now we're going to find the equation. Now we're going to enter this into our calculator. So I'll zoom out here. So we'll use a graphing calculator this time. So I need to get my data. Take my ruler out of the way. First thing you want to do, you want to reset your calculator and go down to 7. Oops, no, I didn't. Second, memory, reset. And I want to reset. So clear all of my previous data. I'm going to follow through with the step before. So number 1, we want to go to my start button, enter, and I'm just following through from instructions from your sheet here. So you can keep that handy with you. I won't refer to that right now. Now enter my data. I have 0, 1, 2, 3, 4, and I went on to 5. That's okay. You don't need 5, but next we have 8. Next we have 7.5. Next we have 7. 3 is 6.5. 4 is 6. 5 is 5.5. Now we have our graph. We go to my stat plot. Make sure you put the stat plot on. You need that guy. Then I go to my window. My window here is from X minimum. I start from 0. So I'm going to go to 0 here. And I make up to 20 maximum. I'm just making up a number. And my Y minimum is 0. So that's the number of snow. And the Y maximum is 8. But I'll make it a little bit higher. I'll leave it at 10. Next, that's my window. And I press graph. Notice it's declining. So it matches up here. Now I need to get my equation. And that's where you press your stat button, go to calc, and go to linear regression, because we said it's a linear regression equation. Okay, so we have a linear regression equation. We're going to go down to number 4. And we go down to store region plus bars, go to Y bars, and press it 3 times. Oops. There we go. And there's my equation. Now, if you go to the Y equal button, you'll also get your equation here, which is Y is equal to negative 0.5x. Oops. Plus 8. Your y-intercept is 8 and is declining every 0.5 of an hour. There's your graph, and there's your line. How long will it snow for it to melt completely? For it to melt completely, it's the x-intercept. So I need to find the x-intercept. In other words, when y is equal to 0, what is x? Okay. So y is equal to 0. So now I'll go to my second trace, and that's found because you're finding your x-intercept, which is a set of instructions, the last set here. So we have our equation. We have to go down to y equals 2 button and make that 0. So now we'll have another equation right down here. It's red on my screen, but you will probably not see it. But if you want to see that line, change your window and maybe put it to negative, go to y negative, -2, and you probably will see it now. So I'm going to see my x-axis. You don't need it. So now we see that line here, y equals 0. You want to find where these two lines meet, and that will give you the x value. That's when the snow, no more snow is melting. All the snow is melted. And then no more snow. So second trace, and I go down to intersect, and press enter 3 times. And that's where it is, at 16, almost close to what I had there. So after 16 hours, the snow is melted. So x is equal to 16. So after 16 hours, the snow is gone. It's melted. Okay, next question. When will the snow melt to a depth of 3.75 centimeters? In other words, you want to know when y, this is your y. Remember, this is your y value. And y is equal to 3.75. What is x? Now we'll repeat the same process now, right? So we go to y equal button, and I'm going to change y equals 0. I'll put 3.75. Because when y is 3.75, which will be somewhere. So this is the depth of the snow, right? So 3.75. So for my guess here, between 10 and 12, but we don't know yet. Let's see what we'll get here. So y equal button, graph button, and I'll get my graph. This is a depth of 3.5 centimeters. So now I press second trace. I'm going to intersect. So when after 8.5 hours, so that'll be 8.5. Okay. So after 8.5 hours, the depth of snow is 3.75 centimeters. And the last part here, what are we assuming regarding the amount of answers to part C and D? Well, C and D, we are assuming that the snow will melt at a constant rate. Okay, that may not happen all the time, but we are making that assumption because the rate of melting will increase the less snow there is, technically. So that's a different set of questions, but for now we're making that assumption. So we say the snow, for those of you who know your science, this is not true, but the snow will melt, or I said the snow is melting, the assumption is melting at a constant rate of 0.5 centimeters per hour. Okay, so that concludes the example questions for verbal description. And by now you should be working on your assignment questions, which is on question 7. So you want to try question 7 on page 38. And also question number 8 on page 39. And this will conclude Unit 3, Introduction to Graphing and Linear Functions. So your next assignment to hand in is assignment 3. And tomorrow, the next lesson, we are beginning Unit 4, Quadratic Functions.